All right, guys, so we're going to move forward in solving angles in circles. So what we're going to look at in this lesson particularly is dealing with angles that don't originate from the center of the circle or on the edge of the circle. We're going to take a look what happens if I have a vertex inside my circle that's not the center or outside of my circle. And there's going to be two formulas we're going to learn with having to deal with those types of angles. So let's move forward here. So two definitions we need to talk about before moving forward. First one is a secant. So we talked about a chord. A chord has two endpoints on the circle. The line cuts across the circle. A secant is a line that intersects a circle at 2 points. So a secant doesn't just end. Really the difference between a secant and a chord is that a chord is a segment that ends on the circle, whereas a secant is a line that continues on to either direction. Okay, so it's a line that intersects the circle at 2 points. Now there's secants and there's tangents. A tangent is a line that intersects a circle at only 1 point. So notice this picture here, this circle and the line they intersect, it kind of comes into line with the circle, touches the circle once, and then continues on its merry way without ever intersecting it again. So it's not really inside the circle like a tangent or like a secant is, but it does touch the circle, and at 1 point it does intersect. So a secant crosses twice, a tangent crosses once. So what we're going to do first is we're going to break these angles up into terms of the vertex being inside the circle and the vertex being outside the circle. So we're going to start with inside the circle. Say I want to solve for some angles. I've got this vertex inside of my circle here, so here's my vertex. And I've got x and y as arcs, and I want to solve for angle 1. Notice what the formula says. The formula says that if I add up, basically if I average my arcs, that solves for my missing angle there. So angle 1 is equal, this is the angle measure, M for measure of 1. And actually, hang on, measure, this should be first, sorry about that. Measure of angle 1, so how many degrees is it? Well, it's equal to 1/2 times x plus y, the measure of x plus the measure of y. Now, notice, let me just talk you through a couple ways that might help you remember this, okay? Notice how the arcs, okay, so this one right here and that one right there, the arcs kind of look like parentheses. If it's on the parentheses, it's going in the parentheses, okay? And then notice how the lines, they cross. It almost makes like a plus sign, and that's going to be the plus sign right there. So that might be a little bit silly, but since some of these formulas are a little trickier to remember, or you want to be able to remember them instead of having to look them up all the time, that's a way that I remember them, okay? If it looks like parentheses, it's going in the parentheses. If it crosses, it's going to be a plus sign. And then the 1/2, I don't really have anything for you there. You're just going to have to remember that it's times 1/2. So let's go ahead and apply this formula once or twice. So notice here, I've got in this circle, I've got this big arc here, I've got this big arc here, and I've got the angle. So what I'm going to do is I'm going to set it up. X is equal to 1/2 times 84 plus 64. All right? And so I could solve that out. 84 plus 64, that comes out to something like 148. So X is equal to 1/2 times 148, which is equal to 74, okay? So basically you're just taking the average of the two numbers, and that will get you your x value, assuming that your x value is the angle. Now in this next problem, notice the x value is not the angle, so I shouldn't stick x out on the side. Notice how x is actually an arc right here, okay? So here's how I'm gonna have to set this thing up. I'm going to have to set it up 70 is equal to 1/2 times 80 plus x, okay? Notice that in this case, my x is inside my parenthesis. Well, why is it inside my parenthesis? Well, it's on my arc. If it's in the arcs, if it's on the arcs, it's going inside the parentheses. So let's go ahead and solve this. There's a couple different ways. I could multiply both sides by 2, but I'm just going to actually distribute this 1/2 to both sides. But I think multiplying by 2 is probably, if I was just doing it for myself, that's probably what I would do, but this is usually the way that people find, this is the way that people tend to think of this problem, so we'll solve it this way. So I get 30 is equal to 1/2 x. And what I'm going to do is I'm going to multiply by 2 on both sides. And so I get x is equal to 60. Okay, just like that. All right, so we dealt with vertexes inside the circle. What happens if my vertex is outside the circle? Well, let me just show you the three pictures and we're going to talk about it a little bit. There's really three ways that this can happen. One way is with two secants. So I've got this vertex out here on the outside my circle, and then my two rays going forward cross my circle twice. Both of them do. That's one way. A second way that this can show up, it would be something like this: a secant and a tangent. I'm trying to get the. Oh, I'm sorry, my page was not scrolling. I was trying to get it to scroll. Here we go. All right, so here's the second way it could show up. It could show up with a secant and a tangent. So notice the secant crosses twice and the tangent only crosses once. Okay, so that'll be the second way. So two secants would be the first way, a secant and a tangent. And then the third way would be that there would be two tangents available. Okay, so notice I get two tangents. Now here's what I want you to notice. Look at the formulas. Measure of angle 1 is equal to 1/2. That looks familiar. X minus y. So notice if it's on the arcs, it's still going in the parentheses. Notice how we're not crossing in the circle. We've just got lines that kind of look like minus signs. Okay, so I'm going to do minus here. Okay, so this works very similarly to the last one, the main difference here being the minus sign. But let's look at the second formula. It's the same thing. Okay, notice how the first formula and the second formula are the exact same thing. And the third formula, it's the same thing. So really, there's three different ways it can appear. There's only one formula to deal with it. And that formula is very similar to the one we did for the vertex inside the circle that was not the center of the circle. So let's set up a couple problems. So notice here, my arcs, I've got 38 in the angle, so that's going to go out here by itself, is equal to 1/2 times, if it's on the arcs, going inside the parentheses. 109 minus x. Now, some people might set this up as x minus 109, but notice the bigger one should go first. Okay, this is my bigger arc here, is that 109. So it's 109 minus x. And then I could solve this out. Just for time's sake, I'm not going to, but the solving is very similar to what we did for that last one with the vertex inside the circle. Let's set up another one, okay? So notice this time it's x in the angle, so that's going to go by itself, times 1/2 times 175 minus 96. Okay, just like that. All right, let's look at this one here, because ones like this sometimes confuse people a little bit. Notice I've got two tangents, and I've got an x and I've got a 132. So if I was setting this thing up, I would set it up, x is equal to 1/2 times something minus 132. Okay? But I don't have that larger arc, right? So what could I do to solve for that larger arc? Well, how many degrees are in a circle? 360, right? And so what I'm going to do is I'm going to do 360, and I'm going to subtract 132. Well, why am I doing that? Well, because with two tangents, what ends up happening is that whatever is part of one arc, which is 132, whatever's left over has to be the other arc. There's no secants here to kind of split up the arc into three different pieces, or the circle into three different pieces. You only have two pieces, so if one's 132, we can solve for the other one. And so we end up with 228. So we plug that in right here. Okay, and then we could solve for x. So with the two tangents, sometimes they give you less information than you think you need, but actually this is enough information. If you have even just one angle, you could solve it that way too. So hopefully this is helpful. I know it seems like a lot, but really the key things here to remember is 1/2 times the addition of the two arcs if the vertex is inside the circle, 1/2 times the difference of the two arcs if the vertex is outside the circle. Hopefully that's helpful. Once again, feel free to reach out if you have any questions.